Good evening and welcome to TL Physics, and today I'm going to talk about the Rutherford experiment. So, the Rutherford experiment was a sort of groundbreaking, the observations that Rutherford made were groundbreaking because it changed the way we looked at the atom. Now originally you had Thomson, who discovered the electron, and he believed in what we call the plum pudding method, the plum pudding model, where we have an atom and basically all the positive charge is spread around this atom here, and we have dotted in it loads of electrons, and it looks like sort of a Christmas pudding or a plum pudding here. And this was the one that Thomson came up with. What Rutherford decided to do was to investigate that holistically. So this is just theoretical, and what Rutherford tried to do is get some actual real data to actually try and prove or disprove this model. So what he did is there's a very thin amount of gold foil here, and what he did is that Rutherford emitted alpha particles through this gold leaf. And because the positive charge of this gold was spread out quite thin, it wasn't concentrated, what Rutherford expected was that this detector here would pick up all of the data. The alpha particles would not be deflected because all the positive and negative are all mingled up together. So overall at any point there'd be zero charge. So this positive alpha particle here has a charge of 2+. We just go through and that is not charged at all, so it wouldn't affect it. But what really happened was this, that in this detector we got sort of maybe about 80%, 80 to 90%. We got about 4 to 5% at these detectors here. But the most important part is that we got a very small amount, 1 to 2%, on the detector that was actually with the alpha emitter. So what this was meaning is that some of these were going straight through, actually most of them were going straight through, but some of them were being deflected, and even more importantly, some of them were being reflected back. And this led Rutherford to start hypothesizing what an atom would really look like and how this would work. And what I've got here is I've got my gold nucleus, that's got 79 plus here, that's my AU, and these are the tracts of this alpha particle, 2+. So most of them went through. Most of the tracks of the alpha particle went through. Some of them were deflected, and a very small amount, but a crucial amount, came back. And what this meant is that the atom, a region we thought completely would be all the positive charge of the atom and the negative all cancel each other out like the plum pudding model. What it really is this very concentrated, so it's got a very concentrated region of positive charge. So it's got a very concentrated, another word that is used sometimes is dense region of positive charge. And most of the atom is just free space. And that built from Rutherford, that built onto our atom that we know today. That built us onto the atom. So not Thomson's sort of plum pudding, that builds us onto the atom that we know today, where we've got this nucleus where we've got protons and neutrons, and then we have these orbits of electrons around it. And it was Rutherford's observations from this experiment that was able to conclude that. So that is Rutherford. Rutherford's data was able to get the basic format of what an atom looked like, to debunk what Thomson had put forward about this plum pudding, and actually bring up this idea that a nucleus has a dense region of positive charge at the centre, the nucleus where protons and neutrons live, and predominantly the rest of it is just free space. That is Rutherford's experiment.